Bismillahirrahmanirrahim. Welcome everyone to this week's Cyber Saturday, where we're going to be solving more CTF questions. This week is going to be special because after the usual beginner-friendly Pico CTF stuff, we are going to look, instead of Hackabox, we're going to look at two recent CTF challenges that we've been solving, and they're very interesting. They're a bit on the intermediate, maybe advanced side, but they're very cool, and I think you're gonna learn a lot. So stay tuned, and I will hand you over to Omar.
Thank you so much, Adham. And let's get started. So today we have, hopefully, we'll be able to solve 4 challenges. And what's interesting now is that we're really starting to get into the more it's getting more advanced. It's not very advanced, but we're getting more interesting and so on. And we're starting to deal with web servers. Most of what we've done so far were static websites. Maybe they hide it in robots.txt. Maybe we need to go through the HTML, CSS. Maybe just look at the JavaScript, decode some base64. But now we're going to start dealing with servers a bit more and cookies a bit more. So it's really getting interesting. Our first challenge today is, of course, a web challenge. It's called log on, not log in. We finished log in last time. Today we're going to do log on. Okay, so what does it say? The factory is hiding things from all of its users. Can you log in as Joe and find what they've been looking at? Okay, and we're given these, it's just the same link. Okay, let's see. Just want to make sure that I have it reset. Okay, let's reset. Okay, so this is what you see when you open the challenge. You see factory login. Interesting. There's a home button. Let's try that. Nothing. Not logged in anyways. Sign out. Nothing because we're not signed in. Okay. Why not inspect the page source if there's anything fishy? Typical comments. Typical, this is the form that we're going to submit from. Zoom in a bit. Typical import, CSS, jQuery. This looks okay. Nothing seems fishy here. Now let's try to make a request to make sure that at least we're talking with a server and not its client-side authentication. So let's see, user 123. Password 123. Sign in. Okay. Of course, you should never use that password because that password is in some data breach. But okay. So, interesting. We see a couple of requests. It says success. You logged in. Not sure you'll be able to see the flag though. Let's see. It made multiple requests, so let's study what was happening. So a post request, it's just a redirect. So let's see the other one. Yeah, found. And this includes our information. And it was redirected again. Okay. So multiple redirects happened, but we got logged in. And then it sent a request to /flag, which is what we're on right now. Which got redirected to the ID, just normal redirection. And the response, of course, is what we have right here. There is no flag. It just says that you're logged in, but we're not sure that you'll see the flag. Okay. So which response has the... None of them have the log. It's fine. So we see that we have a session. Right. So, of course, every time we access here, there has to be something keeping that session. And as we discussed before, sessions are kept using what? Using the cookies. This is how the server can know that you are the same user. Here, in this case, we are user 123 with password 123. Now, they don't have authentication. They just, as soon as you give it any username and password pair, you're automatically logged in. That's a different issue that they need to resolve. But it has to be giving us a cookie in order to keep track of who we are. And every time we refresh, we're not redirected back to the login page because the session is kept alive. So this is, when I do refresh, this is the first request. So this is a request that's giving us this. So let's see in our request headers, the cookies. Okay, this is typical. Okay, this is normal stuff for the server, whatever it needs to do. And then we see the password, okay, in plain text, username again, and then admin equal to false. This is weird. It's just plain text like that. Usually, the cookie will be some string, okay, that it can be one of two cases. Either a string that you can decode, okay, it's not hidden from you, but you cannot change because you need a secret key, or it is something you cannot even see. But in this case, it is literally the word false. There is no session ID, there is no encoding, there is no hashing like we discussed last time. So this is weird. So let's see, if we go to the application and we go to our cookies, we see all of the cookies that were sent in the request, okay, username, password, and admin. So first thought that should come to mind is, here's the admin. Of course, we're not able to see the cookie probably because we're not admin. So let's try to change it to true, capital T, to follow the same format. Okay, now we changed the cookie. Let's try to refresh. Amazing. That's all we had to do, because the server is not validating the cookie. Usually, and let's see, JWT. So one way of creating these cookies is JWT. It's JSON Web Token. It has a special format. The format is header, okay, encoded in base 64. We discussed base 64 last time. If not, let's give a quick recap. I think I have it. Yep. This is from the, where is it? Where did it go? This was from CyberChef directly. So we tried CyberChef last time. Base 64 is an encoding. Now there's a difference between encoding, encryption, and hashing, okay? Encoding, which is what we care about now, does not provide any security in any way. It is, like we said, it's like translating from English to French, okay? All of the content is there, it's readable, and you can reverse it without needing any secret or any special tools, no. You go from English to French, you can go back from French to English. In this case, you can go from your normal ASCII characters to base 64. Let's say this is my string, okay. Let's copy it. Now we have the string. Let's go from base 64. Nothing needed. We did not provide a key. It's just a different looking text, but the same information. So it encodes the header in base 64, and then it has a payload. Okay, any data you want to save, like admin true, the session ID, anything. And then it has this very interesting part at the tail. It is the signature, okay? So what is a signature? Basically, a signature, what it achieves is this cookie, okay? This whole thing will be sent over the internet. The server will send it back to the client's browser. And they can read all of this, no issues. It's fine. They're supposed to read it if they want, it doesn't matter. It's encoded, not hidden. However, this signature is created by hashing, and we'll show what hashing is in a second, by hashing this plus a secret key stored on the server that no one else knows. So if you change just one thing in the header or payload or whatever, it will change the entire signature. And because you did that, the server will now check when it receives your cookie back. It will take this, okay? It will add its secret, okay? And then it will hash it. We'll show what hashing is. And it will compare the result. Is it the same as what you sent? If not, it knows that something has changed, okay, something is invalid, and what you sent is invalid, and the whole cookie will be discarded. So it is not hiding the data, but it is guaranteeing that the information does not change. So the user can change it on their side, but it will be detected from the server. So let's see. I believe CyberChef has, yeah. So let's see. Let's see. Same message. Amar123. Okay. MD5 is a type of hashing function. There are many hashing functions out there. There's MD4, there's shell hashing, so many different types of hashing functions, but their goal is always the same. They take any size input, okay, and they turn it into a fixed sized output. What does that mean? It doesn't matter how much text I add here. The length of this hash will always stay the same. Okay, that's one thing. It's always the same. So it's sort of compressing it in a sense. Another thing you'll notice is this is Omar123. Okay, this is the hash 98 and ends with 81. Let me just change one number 123 to 124. Completely different hash 70 and then ends with 00. If I add 5, for example, just one more character, completely different. That's the whole purpose of a hash function. A tiny change in the input will lead to a completely different output, a completely different digest or hash output. And this is how it can detect. So if let's say we had, like in the server example, the factory login, it said admin, we can have it like this, equal to false, we had originally to false, and then it ended the curly braces. Let's say it had it in this format. This is one of many ways we can have it, okay? It's BA blah 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 77. Let me just change it to true. Immediately, it changed completely. So that the server will be able to detect it with ease because it has the secret key on its side. So now we understand hashing. We understand how a token should be. JWT is a secure way of maintaining sessions and cookies. And now we understand why they were doing it wrong. They were putting it in plain text, no validation mechanism. The user can change it, and the server will accept it, which should never be the case. Okay, that's good. First challenge down. Now we understand a bit more about cookies, about hashing and encoding. Let's see the second challenge we have. Who are you? Interesting. This one will be interesting because we're going to do a bit of programming and scripting. Okay, let me in. Okay, someone is definitely kicked out of the server. Let's see. We go in. Only people who use the official Pico browser are allowed on the site. Interesting. Okay, let's just do the usual thing. Is there anything hidden? Nope, looks fine. Okay, so immediately when we hear Pico browser or any browser, the way for servers to detect which browser you're using is, of course, using the HTTP headers. So as we discussed before, the HTTP, let's see here, sample HTTP request. Yeah, it looks something like this. Is there another example? I don't know why this is illustrating an attack. Okay, this is you start with specifying the type of request. Is it GET if you're just grabbing data, or POST if you're sending data to the server, and then the path or the URL you're going to. And then here we have the headers, the host, content type, user agent, and many other possible headers that can be here. I think like there's hundreds of them at this point. And you can even specify your own custom headers and send it. That's also possible. But what we notice here is user agent. Okay, Mozilla. Okay. So this is probably, they're talking about Mozilla Firefox. Yeah, here, Mozilla Firefox. And even if we go into our own request, let's go to the network tab. Let's refresh to make the request one more time. And here is the request headers. This is what we sent. Okay, here it's just formatted and much better looking. But yeah, it says Mozilla /5.0 Macintosh. Okay, Intel Mac, Apple, blah blah blah, Chrome, version 1.2.2. So this is exactly what I'm using. I'm using Chrome version 1.2.2. So the user agent is used to specify the browser. Okay, it's called the user agent. So let's we can specify this in curl, or we can do it in Python, whatever. We tried curl before. Let's try doing it now in Python. Let me open up my code editor. I'll create a new folder. Pico. Okay. Nice. Now I have Visual Studio running. Okay. Let's call it who are you.py. Let's turn off Copilot because it probably has memorized this challenge by now, so it will give us very direct hints. So how do we make a request in Python? There is a library called requests. As simple as that. It's used for making HTTP requests. I think here is the description. It is an HTTP library written in Python for human beings. It's very, very simple. So let's say we want to make a request. Let's call it the variable request. Actually, let's save the URL. Where are we going first? We want to go to this URL. Ctrl+C, Ctrl+V. Let's make the request. The request is going to be requests.get. We want a get request. As we saw from here, it was a get request. We're not sending any data. We're just asking the server for that. And that's it. We pass the URL. Let's print the request.text, which is the body that is returned. Let's run the code. And we get the exact HTML that we were looking at. Yeah, only people who use the official Pico browser are allowed on this site. Okay, so this is where they specify their conditions. So how do we specify headers? Well, that's very simple. We're gonna make a dictionary of headers. A dictionary is key value pairs, like we saw in the cookie, for example. Admin, true. Name, Omar. ID, 1, 2, 3. It's just the keys and the values, keys and the values. So we want to specify the key, user agent. We want to try Pico browser, even though it doesn't exist, but maybe they're checking for it. So we specified our browser using the user agent. Now let's try to, let's put it in the request. So we do headers is equal to headers, as simple as that. Now we have this header. It will change the user agent from, I think the default is Python, Python something, to Pico browser. Let's see if we get anything different this time. Okay, it changed. Their condition now says, I don't trust users visiting from another site. Let's see. We didn't actually go into the headers website. So yeah, where is it? So of course we talked about user agent. Yeah, so this is the one that we talked about, we discussed. Okay, here's here they have very, very, very detailed documentation, but now it is telling us I don't trust users visiting from another site. Okay, actually, let me do one thing. Let me, so we can see the output. I'm going to save. We'll call it site.html. Okay, all I'm doing is creating a file called site.html, and I'm opening it with write permissions. Okay, so I can write to it, and I'm calling it the variable file. So I can do file.write request.text. So we can just see it. Now I can go here. Everything is written. I have a go live extension. I can. Amazing. Okay, the image is not loading, but that's fine. I don't trust users visiting from another site. Let's Google HTTP header Let's see, famous HTTP headers. Okay, except this is the media type, not really important. User agent, we already know it. Authorization, this has to do with the cookie, the JWT token we were talking about earlier, but no. Content type, nope. Cookie, nope. Content type, cache control, server, they don't seem to have it. But okay, let's try HTTP header for specifying. You know what? This is the perfect time to chat GPT, because they don't offer us the name of the header, but they give us a general direction. تمام? So this is what we can use natural language processing for. ChatGPT. Okay. So list the HTTP headers that can specify what do they want? Yeah, that I'm visiting from another website. That can specify that I am visiting from a different site. Oh, this is interesting. Okay, when you visit the website, several HTTP headers, there is the referrer. Okay, this header is perhaps the most direct way your browser communicates that you are visiting a site from a specific URL. Okay, it contains the address of the previous web page from which a link to the currently requested page was followed. For example, if you click on a link on example.com that takes you to another site.com, the referrer header in the request to another site will include example.com. Interesting. This seems like exactly what we want. There is origin, but it's used primarily in post requests, so we don't want to get into that. We want something in the get request. So it seems like referrer is exactly what we want. And they said, I don't trust users visiting from another website, so they probably want us to put the referrer as themselves. So we're accessing them from them. Okay. Referrer. Let's put the same URL. Why not? Okay, now that should be updated. I'll go to the HTML. Oh, sorry, this only worked in, I'm sorry. Sorry, this only worked in 2018. Okay, that's weird, but okay. Let's see. HTTP header for date. You can use ChatGPT or not, but here it's more straightforward. So yeah, there is a literal date HTTP header that you can use. They have a specific syntax. Day name, okay, and it can be the 3 letters, so the 3-letter abbreviation, and then a comma, a space, and then the day, the month, the year. Oh my god, wow, it's very specific. Space, hour, minute, second, and then space GMT. Okay, so usually when you see a syntax, you will find these angle brackets. They specify something required. Okay, if you see the square brackets, so let's say name, okay, that means the name is optional. So that's just a way syntax is described. Okay, now we have an idea of the second parameter. So let's try building it. So they need us to specify the date. It's going to be a string. Let's pick any day. I don't know, Thursday. Let's say 1 January 2018. Actually, let's make it a bit into the year itself, so we avoid the issues. Let's say anytime. 10 GMT. Okay, let's try it now. Did it update? Did we bypass it? Oh, nice. I don't trust users who can be tracked. Okay, let's try Googling HTTP header for specifying being tracked. Oh, there's something for it. Let's read. Honestly, I like the Mozilla docs better. Okay, DNT deprecated. This feature is no longer recommended. Some browser may still support it, blah, blah, blah. Well, the do not track request header indicates the user's tracking preference. It lets users indicate whether they would prefer privacy rather than personalized content. So this seems like, and I used this header. Honestly, no wonder they deprecated it, because browsers will still track you whether you specify not or yes. So yeah, it's a simple header. Do not track 0 or 1 or null if you don't want to specify it. You might as well just not write it. Why just write null? But okay. So 0 is the user prefers to allow tracking. No, the user prefers not to be tracked. This is what we want. So we want to set the do not track header to 1. Please do not track me. Okay. This website is only for people from Sweden. This is an interesting one. Yeah. Yep. Adham, go ahead. How did I redirect requests to browser? Oh, having it here? Yeah. So there is I'm using an extension, honestly. So when we make the request, I wrote it to a file called site.html. I just took the HTML from the request, from the response, and I saved it into a file. Okay. And I have an extension. Share it. Extension live server, I think it was called. Yeah, live server. Basically, it's an extension in VS Code where you go to whatever site, .html, the simple static stuff, and it's usually going to be like this. Yeah, go live. You click it. It will create a server for you that you can. That will automatically live update as soon as changes happen. Some advanced port forward proxies. We'll leave that for other challenges. Soon we'll get into that, hopefully. But yeah, this is a simple static website setup. You can set it up in many ways. You can do it in Python, or you can just open the file literally in. You can do file, then 3 slashes, and you start opening the file directly, the HTML file. You specify the path on your computer. That's fine. Google Chrome allows you to do that. So there's multiple ways. But yeah, now this website is only for people from Sweden. Okay. So HTTP header for specifying the location, maybe? Is this what we need? No, this is talking about the literal the location of the URL, which is not what we want. We want the here for header HTTP header location country. Okay. Mostly they're talking about the. Let's try geographical maybe. Let's see what's this geolocation header. Okay, they're going to start. They're going to give us the whole RFC before they can tell us about that. Oh, interesting. I never heard of this. Is that? Oh, what? I'm honestly learning about this now. I've never seen this geolocation header before. It seems like it's some testing stuff. Reference location information. Oh no, it's talking about the request itself. A location on the request. but this could be used to select content that is more appropriate for recipient at a given location. Okay. It doesn't seem to be the one. It seems to be like an experimental thing. Well, here's the thing. We also know that how can they know the location? Well, of course, the IP. So it's probably not going to be a literal string. We write Sweden and now they just believe that we're in Sweden. We actually have to specify something that proves that we're in Sweden. So let's try HTTP header, specify our IP. Your IP. X forwarded 4. Okay, the X forwarded 4 is a de facto standard. Okay, so it's a standard for identifying the originating IP address of a client connecting to a web server through a proxy server. Okay. Let's see what it looks like. Elements are comma separated with optional white space surrounding the commas. So the client IP address, and they give us examples. Okay, X forwarded 4. So this is to specify our IP address. Okay, so we can use this, but we actually need to find an IP in Sweden. We cannot just put any arbitrary number. So let's Google IP addresses in Sweden. Okay. I hope okay. These are all really interesting. So they give us ranges of IP addresses. So we can take from the middle of the range. Let's pick any one. Okay. We're going to take this IP address, which is presumably in Sweden. Okay. And I'm going to use the same, X forwarded 4 URL, sorry, HTTP header, which takes an IP. I'm going to put 4. The reason is because 0 is usually reserved. Honestly, I honestly forgot a bit of computer networks, but maybe it will be used to the, no, not the gateway. Well, anyways, let's just pick in the middle of the range. We have 256. So let's just be safe on the safer side. So let's see if it works now. Did it work? No, this website is only for people from Sweden. So we did not bypass the restriction. Okay, let's try. So these are the telecommunication, hosting, router, IPs. I think IP info is, important. Routers. We're gonna take the routers. We might as well try it. It's in Sweden, so why not? Oh, it's okay. Let's pick anyone. These specific IPs, so hopefully it will work. Yeah. Let's try. You're in Sweden, but you don't speak Swedish. Okay. So we made it through. So the router, so we just got some IP for a router in Sweden, and it worked. They're probably using the IP info API to check it. They have an API that tells you the location of the IP and some other information. But yeah, so now we bypassed the location. So now it believes we're in Sweden, but we're not speaking Swedish. So we probably need a header to specify language. Because when you access when you open incognito, for example, here in the UAE, you'll find that Google by default goes to Arabic, for example. Or when you go to another country, it will go to a different language by default. So how does it know? It's probably using this header. So the accept language request HTTP header. Let's read about it. Indicates the natural language. Okay, so the the human language that we want to choose, and local that the client prefers. Okay, okay, okay. Extra information. Let's see their examples. So accept language, and these are the languages. But what is this Q? I honestly never understood it. I always see it, but I never understood it. Q factor weighting. Any value placed in an order of preference expressed using. Wow, okay, so this is. We're doing math to specify the language. That's that's interesting. But let's see. Okay, so we know the header, but we want to see what is the code for Swedish. HTTP accept language list. Oh, there's Swedish. Probably people were looking for to solve this challenge, but let's see. Let's look for it manually. There's no way these are the only languages supported. It's language codes. Yeah, we're gonna use Internet Explorer 4. Why not? Wow, all of these are for Arabic. Interesting. I never came to this website. Oh, so Swedish is SV. So thank you, Internet Explorer 4. You're very useful, more useful than Mozilla Firefox, apparently. That's updated 1997. Wow. Okay. So we said we want to use the accept language header. So it's good. This is teaching us a lot about headers and so on. Okay, I didn't make the request. Okay, request is made. Did I bypass or? Oh, amazing. What can I say except you are welcome. HTTP headers, very cool, much wow. They are very much cool indeed. We are done. Okay, let's jump to the next challenge we have. Where did my browser go? Okay, includes. So this one is very simple. This is like a 2-minute challenge. The next one includes. Can you get the flag? Go to this website and see what you can discover. Let me turn off these. Let me close them maybe. Okay. On includes. Many programming languages and other computer files have a directive, often called include, sometimes copy or import, like we saw in Python, that causes the contents of a file, a second file, to be inserted into the original file. These included files are called copybooks or header files. They are often used to define the physical layout of program data, pieces of procedural code, and or forward declarations. This is like Wikipedia definition. While promoting encapsulation and the reuse of code. Source, Wikipedia. Okay. How was it wrong? Say hello. This code is in a separate file. Let's see the page source. So we see style sheet, and then okay, a script, and then on-click greetings. So of course the function is not defined here. It's not in the HTML in a script tag. So it has to be in the script.js tag because there's no other JS being included. Okay, function greetings. This code is in a separate file. So this is the function that we were talking about, and we have this flag-looking piece of text. Let's save it. Save it. It seems like it's missing another part, but let's see. Just like we imported a script to be used in the HTML and manipulate the HTML, we can also include a CSS. We don't have to. You can write it directly in the HTML between CSS. Sorry, what was it called? Style tags, or you can import it from a file, which is what is happening here. So let's see this file. It's a very simple CSS styling, and Pico CTF. This has to be 1 of 2. And I think, did we have the 2 of 2 part? Yes, we have the 2 of 2. So we should be done. Fast challenge. All it's teaching is including files. In HTML, you can include JavaScript code to add functionality to the website and manipulate the elements and do forms and so on. And you can add CSS in a different file to style your website. And just like we did here, we imported someone else's code who wrote a library for making requests, and we're using it. We're using it here, request.get. We're using it. So we include it and we use it. So it's a fast challenge. Last one is a very interesting one. It is not really a web challenge, honestly, but it is very interesting nonetheless. Regex. We've played around with regex before. We did some grep. We tried to extract the flag. We tried to do so, when you try to automate it. So we have some experience with get, but let's see, how about trying to match a regular expression? The website is running here. So let's just try anything. 1 to 3, what do I get? Wrong match, try again. Okay. Eco CTF maybe? Oh, wow, that works? It shouldn't be that easy. Wow. But anyways, let's see. Let's say they have a file. That file had, so many. Let's just get some generator. Okay. Continue without supporting. Just give me, okay, this is just generate placeholder, boilerplate, useless text. Okay. And let's say, sorry. Let's say in the middle, okay, we had the flag here. Pico, CTF, my cool flag. How did we write it? Like this, I think. I hope, yeah. So let's reset this. Okay, now we have nothing. These are just global search, whatever. We don't really care about that. So we want to learn the basics of regular expressions. So you can match for literal words. Okay, so you can do Pico CTF. Okay, but this will only match for you the literal word CTF. This is the same thing that you do in Microsoft Word when you're searching, or anywhere, or when you do Control F on a website. This is what is happening, literal string matching. Okay, so this is cool, but we want something more powerful, something to give us exactly what we need. So we notice that we start with curly braces, and that's fine. Okay, now what is inside? We don't know what's inside, but we know it follows the format of this Pico CTF and then some text. Okay, some text of arbitrary length. We don't know the length. We don't know which characters and in which order. Is there digits, no digits? We don't know. So there are character classes, as you can see here. So these are special characters. So when you do a dot, for example, you're not matching the dot. This is actually matching any character except the new line. Okay. But it's matching only one character. We want more. So here's quantifiers and alternation. So if you specify some specifier, okay, and you add a star after it, it means 0 or more. If you add a plus, 1 or more. If you add a question mark, 0 or 1. So let's see, this will only work if we had, the one we have currently, if we had Pico CTF and then just one character, and then, yeah, that's it, works. But we don't know. It could be 2, you know? Are we going to keep adding dots and brute forcing it? No. We're going to automate it. And we know it's going to be 1 or more. So we just need to add a plus. So what this means is, okay, look for the exact match Pico CTF, open curly braces, stop. Look at any character, any digit, okay, 1 or more times, and then ends with a closing curly braces. So this will match this, it will match this, it will match 100 characters in the middle, it does not matter. And of course you can specify, you can be more specific, you can have more granular control. So here, this is good enough for our purpose. But we can also specify, as you can see here, /W for word, which means like A to Z, small letters and capital letters, /D for digit, and /S for white space. Mainly we want these two, word and digit. So let's try /digit, okay, 1 or more times. So this will match this. Good. And then if we had, for example, just A, for example, ABC, blah, 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 we can use /word. Okay. /word apparently includes digits. Okay, that's even better. So /word, if we go to where is it? No, not cheat sheet. Reference, character classes. Yeah. /word matches any word character, alphanumeric and underscore. Okay, only matches low ASCII characters, no ascending, non-Roman. Okay, so this will match anything A to Z capital, A to Z small, 0 to 9, and underscore, which is perfect for our case. It's like they made it so you can detect flags. They made the character set to detect Pico CTF flags. So this worked. I'm honestly disappointed that they let this work, but what would have been more interesting was what we crafted, the dot plus. And we get the flag, and we deserve to get the flag, not just Pico CTF. But yeah, we get the flag solved, and now we know a bit about regular expressions. So to recap, we did a bit of cookies, we did a bit of playing around with HTTP headers, we learned about including files and imports, and we concluded with regular expressions. And now I'll turn it back to Adham. Adham, go ahead. Thank you.